Hello, welcome back to the HTH 2021 CTF Solve video series. In this video, we're going to be taking a look at the third and final web challenge. So let's go ahead and get started. In this web challenge, we are asked to check logs. So in this particular case, it tells us that it's a solo challenge, should have only been done individually. And what we're looking at here is a log viewer. So let's go here and it's going to tell us, welcome admin. We've previously logged in as min, so we should be that administrator. And it's going to tell us to go ahead and pick a log name to try to view. So in this case, it tells us log text. I'm thinking flag or flag.txt. All of the stuff here is from previous testing, obviously. So we'll go ahead and hit view flag, and it tells us hacker detected. Okay, so there might be something that it's looking specifically for flag. So maybe I could do space flag.txt, maybe fool the initial check by padding it out either before or after with some characters that will probably get stripped away when it goes to do whatever it's doing. Nope, not again. So one thing I might be able to do is just say, okay, what about, I don't know, blah.text and see what happens if the file is invalid. Oh, okay. So now we're getting some information. Error in command, and it gives us with a whole bunch of spaces, kind of interesting. It says command cat blah.text returned a non-zero exit status 1. So this is cool. This shows us, and we were able to leak a little bit of information from the back end. So the server, when it takes our input, is going to take cat space, put our input there, and very likely pass that to like a system call. On the back end, we don't really know what's running this. It's actually a Flask app, so it's Python that's running it. What's really happening is it's taking our information and passing it directly to system to be executed. There's a whole bunch of permissions set on the back end that should prevent you from deleting anything or doing anything like rebooting the system or deleting flags or anything like that. But you should be able to do things like navigate the file system, cat certain files, figure out where you are. But it's a little janky and the output doesn't look very nice. But this is good. Like when we see things like this and we enter input and the server tells us what we're doing, it's actually like playing a game of hot and cold, right? So if you're looking for something and you say you're getting warm, you're getting warmer, you're getting really hot, oh my gosh, you're on fire, you're really close. Or somebody telling you you're getting colder, oh my gosh, you're a popsicle, things like that. This is what that's like. And we want to use this information to our advantage to try to understand if we're getting closer. So throw in things that are oddball, throw in things that are Unicode encoding, throw in weird special characters, things that are commonly, comment characters. So like a hash or / or -- semicolon, whatever it is in different languages. Try those and see what happens. Throw in long strings, throw in short strings, throw in nothing, throw in spaces. All of this stuff helps you try to elicit information from the back end. And when we can do that, when we can tell the server to cough up more information about whether or not we're getting closer, we typically call that an oracle. It's an oracle because it's telling us information about something that we don't know about. It's sort of like predicting the future. It's telling us what we're doing. And that is the worst case, for security. This thing should always say invalid input, and that's it, right? Or just redirect us to the same page and say try again. Give us as little information as possible, right? So if you do something like type in the password incorrectly and you say invalid password or password too long, password too short, all of these things give you information about this. All right, so enough talk. Let's go back. So how can we do this? Well, I know that if I type cat something, it's going to do it. So what if I did cat.blah and then did like ls-l? Oh, okay. So what we did was we chained two commands together with the semicolon. So what happened was I was able to say cat this file, which doesn't exist, and then it'll go to the next thing and say, okay, run ls-l. It gives us this really wonky output, but if we open up Sublime Text, get rid of that last one, or any text editor, we should be able to get some information that's kind of nice back. And I think this is probably, oops. Gotta figure out the best way to sort all this stuff. Good here. So there's tests, the real flag. This actually comes under a test directory. And then there's a flag directory. So we have a couple of things. There's actually a test directory, test.txt, log file.txt. So let's take a look at this log file.txt and see what's here. I wonder if people made that. I don't remember that actually being there. I don't think they should have been able to write. All right, so there's nothing there in log file.txt. Let's go to log.txt, and it's just catting these out. This log file is empty. That was definitely there. Test.txt. Okay, nothing. Interesting. I wonder if people were able to actually write files. Okay, so what I will do is I could do something and then do ls-l do actually what I'm going to do is ls test. Excuse me. ls flag. I wonder what test has in it. Well, it's not showing me anything. Let's do ls flag. See what might be in there. So there's only one file in there, and it's called the real flag. All right, so this should be pretty easy. When I'll come back here, instead of doing ls flag, I will just do cat the real flag. Or what I can do is just have it do this, right? So it returned non-zero exit status, so that didn't work. Am I doing my slashes the wrong way? Hacker detected. Oh, okay. So what it's doing is showing us that there are certain things that it's checking for. Flag.txt alone, it will tell us that, hackers detected. Any type of / will tell us that a hacker's detected. So we need to avoid using this /. So you have to think of how we can either format our input or change directories or do something while we're training these commands to go around this really a dumb input filter. And on the back end, there's really only two things that'll trigger the hacker detection. One is if you just type in flag.txt alone as any token, it will alert. If you have any / it will alert as well. So one of the ways that we can do this is first sort of bypass the first cat whatever by doing this, semicolon. Then I will go ahead and do cd to enter or change directory into the flag. And then I will finally do a cat after that. And hopefully we can get it. And we do. So in that case, it's really all about, and the challenges that I saw people running into with this particular one is I see this file, and unless it's trolling me that it's the real flag, it's there, but I can't do a / because it catches me, and I can't find a way to encode it. How do I get into that directory and still cat it out? And it's really just the realization that, I don't actually need to do everything all in one go. I can actually break it up into multiple parts. And this is so much what this type of challenge is all about. And pen testing or anything is thinking about how the developer could have made this. How would you make it if you were a developer? And what are just sneaky, tricky ways to get past those types of filters? Most of the time, if you roll some type of user input filter yourself, you're going to miss something. And those are, I think, some of the most fun challenges to do because it's a lot of guess and check, and you feel like you're getting closer and closer, and you finally get it, and it's a really rewarding experience. So that is the final web challenge. After this, we'll be going on to, I think, the crypto challenges. Stay tuned.